Luma AI develops technologies at the forefront of AI and graphics. They created a text-to-3D tool that functions like Midjourney, but for generating 3D models. Another tool makes photorealistic environments by reconstructing any scene in 3D from just a few photos. Karan Ganesan is a software engineer and Barkley Dai is the product and growth lead at Luma AI. They join the show to talk about the origin of the company and the technologies it uses. Gregor Vand is a security-focused technologist and is the founder and CTO of MailPass. Previously, Gregor was a CTO across cybersecurity, cyber insurance, and general software engineering companies. He has been based in Asia Pacific for almost a decade and can be found via his profile at vand.hk.
Hi, Barkley and Karan. Welcome to Software Engineering Daily.
Great to be here.
Yeah, so it's great to have you both here today from Luma AI. But yeah, before we dive into what Luma AI is working on, let's hear about both of your backgrounds and like how did you get into this, what is kind of a fairly niche area of 3D AI. So maybe Karan, do you want to start us off?
Sure. Hey folks, I'm Karan. I'm currently based out of India. So I was working in the VR AR space since 2016, building a lot of applications and prototypes and sort of trying to understand what the space is. And then I ended up working in two companies and then ended up working at a corporate like Flipkart, where I was doing a lot of 3D and AR capabilities for a lot of brands and companies. And eventually when I came across Luma, right, kind of the thing that we are working on is like the foundational content for the future, whatever people call as metaverse. So I kind of naturally sort of came across this and started learning about it and here working on it. So yeah, that's a short intro about me.
Hi everyone, my name is Barkley. I'm currently the product and growth lead at Luma AI, doing more on the growth side, but also support our model on the research side. Previously, I worked as a product manager at TikTok, where I was the PM for TikTok effects. So during that time, we were building a lot of these visual 3D effects, but also focus a lot on generative AI ever since it becomes popular in 2022. I was working on a lot of these face changes that using AI to generate different visuals for people doing style transfer for them into different backgrounds. And as I was looking more into these AI to generate 3D, to reconstruct 3D, that's when I found out about Luma. And then I think it's a really interesting field that prompted me to think that, if this could be something that's going to be the content for the future, this might be it. 3D might be the answer. So that's why I left TikTok in 2023 and joined Luma, focusing more on growth side and product side of things.
Nice. So let's maybe also just hear a little about what led to Luma AI being formed in the first place. I think it was in 2021.
Yeah. So our founder Ahmed was working at Apple before starting Luma, and he was working in all the research and camera research for the Apple Vision Pro that got released a couple of months back. And then he was in the forefront trying to understand what are the new things that can come up with rendering, building content for 3D and XR and VR and those kind of things. And that's when Ahmed sort of came across this idea that he wants to come out and build this sort of platform or product around this technology called neural radiance field. And I was very the paper, the neural radiance fields, the first paper came out in 2020, and within a year he was talking to a lot of people, partners, investors and whatnot, and trying to figure out what can we do with this tech and what can we productize, right? And that's when he sort of came to this conclusion that a company should sort of build on top of this tech and build products, right? And also build it cross-platform, sort of go beyond Apple ecosystem, go Android, Windows, or web and all these kind of things, right? And that's where Ahmed saw the opportunity that something can be done, and that's how Luma got formed in 2021. Yeah.
Awesome. I like kind of bringing all those things together, getting the ideas from different places. But I've used the platform, so I can kind of visualize what happens, if I jump in now and use it. But I think to kind of set the scene for the listeners, probably completely new, or maybe completely new to Luma. I think a majority of our listeners may be almost completely new to this field at all. So just to kind of understand a bit more about the Luma products. Can you kind of explain like what would I see if I was just to go into Luma today? Like what are the products and like how do they at a very high level kind of look and operate?
Yeah, so Luma AI as a company, we have two major product lines right now. One is what we call Imagine, which is being able to generate 3D from text. So that's more on the generative side of things, aligning with some of these like recent text to image and all of these like AI generation stuff. And I would say it's more like a 3D version of Midjourney, where you can generate anything from just a simple line of text and with some prompting, and then you get a 3D model in any of these majority of this 3D format to be able to export it and then be able to use as in games, in e-commerce, in a lot of like different fields. So that's on the Imagine side. On our separate product line, which is where Luma started with, is actually the Capture side, which we currently call the product Interactive Scenes, which is basically reconstruct anything in reality, an object, a scene, just by taking a series of photos. And then under the hood is using either neural radiance fields, so NeRF, or Gaussian spatting to construct these 3D interactive scenes from the image that have been taken. And a lot of times then that means after you take around like different aspects of that scene from different angles, you'll be able to construct it as if you were re-experiencing that, as you are recreating that scene into this like virtual space just as it is in real life. So that's more what we call the Capture product, which is more for people to reconstruct some of these like reality, these objects from their daily lives into our virtual app.
Got it. Okay. So yeah, there's the two products effectively, as you say, like interactive scenes, Capture, and then Genie, which is the generative product, like text to object effectively. Maybe let's just take for a second the interactive scenes. So as you both mentioned, the kind of key underlying tech here is neural radiance fields, or NeRFs for short. Again, I'm going to guess a majority of those listening maybe have zero knowledge of this, or maybe only a small understanding of what they even are sort of at a high level. So maybe can we just dive in a little bit to like what are NeRFs basically?
Sure. Tried to explain this in a different bunch of ways, and I think I found the like right way to sort of explain it. I'm going to just say that right. So today we have things like JPEG, PNG, and like all these 3D like image formats, right? And like PNG is like the highest quality where it's like lossless, and it's basically a grid of colors in a like sort of grid where you just each point has a color, right? Now in the highest level, it's basically similar to that, but in a 3D like in a 3D way where you have X, Y, Z coordinate, but also you have one more thing like the angle at which you're looking at. So it's like 5 parameters, the position that is X, Y, Z, and also like the alpha and like theta values where you can like it basically denotes where you're looking from in like 3D space. Now with these 5 parameters, that's basically what neural radiance field is. Like whenever you are trying to see something, you are basically querying with these 5 parameters and like sort of getting an output for each like from the angle that you're looking at. So that's kind of how neural radiance fields work. And in terms of what Gaussian splats are, right? Now, neural radiance fields are GPU intensive, where we are querying a neural network to sort of get these values based on these 5 parameters. Whereas in Gaussian splats, like with the research that happened in the last few years, it's kind of an explicit representation, whereas neural radiance fields is like an implicit, where Gaussians are basically like a bunch of spheres or some random shapes with random sizes also, and like they are computed and like they are just placed so that you don't have to query them. Now they also have this color thing where when you look from different angles you see the color. That's basically how Gaussian splats work. Basically it's a point cloud with different shapes in it, and you just basically query by saying where you're looking from. So yeah, those are basically like how NeRFs and Gaussian splats work from a top level.
Got it. And do you know like where did I guess both of these concepts kind of originate from? Academia, or was there some other kind of application they were brought in from?
Yeah.
Yeah.
It came from academia. Yeah, it came from UC Berkeley. One of the early authors' name was like Matt Tanek. He's also is working with Luma right now. And like, yeah, it came out of UC Berkeley, basically. Like the lab the AI lab that they have, that's where they sort of worked on these things.
I see. And you have, I think you just mentioned, he's actually an advisor at Luma or part of Luma as well?
He's part of Luma. He's one of the applied research leads here.
Awesome. Okay, yeah, it's nice. Okay, so quite a strong link there, to say the least. So let's also, I guess, move to so that was kind of the underpinnings of the capture product, the interactive scenes. If we also now just move to Genie, which is, generating objects from scratch. So again, if I can just, for example, I went in there and I typed a mug with a car racing team on it, because I have a mug on my desk that has that. So I was just like, let's just see what it comes up with. So if you can imagine as a listener, that's, just type in an object and then I got a nice set of 3 mugs that I could do something with. And we'll maybe talk about the something with shortly. But yeah, so in terms of Genie as a technology, what is actually happening here to kind of go from I type in a sentence or just 2 words and then we come up with an object?
Some of the tech that we use for Genie kind of correlates to what we did for Gaussian splats. It's kind of a similar sort of underlying representation. But the key difference is for the capture product, we have the images that the user took as reference to sort of make the 3D model, the 3D representation. But for Genie, we don't have a end output, right? So what we basically do is we start from a black image or a noise image, sort of set of frames like that. And we basically say that try to come as close to this particular mug with a racing car or whatever, right? So it's like a iterative process. You just start running it and you have to keep running it until you see the output. Basically we kind of sort of used a lot of 3D models and images as reference to sort of work with this. So that's how it kind of works. Based on the data that we have and train, we sort of try to make something that's relevant to what the user said. And that's how basically sort of Genie works. And as I mentioned, underlying it's still Gaussian splats, but we convert them to traditional 3D formats when we show it to the user. So yeah, that's how we sort of come to an end for the product.
Got it. So yeah, my next question was going to be the relationship, I guess, between. This is, I'm sure for some listeners out there, this is such an obvious question perhaps, but the relationship between NeRFs and Gaussian splats, and then actually this sort of newer product text to sort of 3D object. The relationship is mainly the Gaussian splat piece, or NeRFs as well, or yeah?
Mainly Gaussian splat representation, just because they are easy to they are less GPU intensive, whereas NeRFs are you need a beefy GPU to even use them. So yeah.
Yeah. Okay, that makes. So I guess maybe just kind of, if we look at the Genie product itself, I guess 2 questions. I guess what was the driving force to get from the interactive scenes product to Genie? I'm taking a guess here. Maybe is it to do with it's more accessible, for example, as you say, it's less GPU intensive, i.e. more accessible again. But what are also the kind of the applications that you see for the Genie outputs?
Yeah, so I think the Genie part, which is text to 3D, we actually started to do that even before Gaussian splatting comes in place. So being able to generate 3D objects has always been a goal and a mission for the company, even at a really early phase when we don't have the interactive scenes in place. But after that, we just see this opportunity that there is this breakthrough that we can make in generating 3D objects from text. But I think the underlying reason is creating a 3D object is really hard. And actually using our capture product to create a 3D representation of something in real life is also quite labor intensive. For an average person to know how to create a good NeRF or Gaussian splatting requires them to take the phone and go around an object, circle it at least 2 or 3 circles to be able to capture every details of it. But on the other hand, for Genie, what people could do is just type in text, which basically takes less than 10 seconds, and then they will be getting something. Although it may not be realistic, it may not be exactly the thing that they see, but they can then use that 3D object in subsequent pipelines or in their games, in some of these e-commerce applications, in some of their 3D designs, which is much more easier in terms of creation flow compared to our capture product. So I think these always takes hand in hand. If someone is more caring about the fidelity, caring about the actual real life representation, and being wanted to capture the surroundings as part of their memories, as part of their collections, they will go to the captures. But if they want to generate 3D objects quickly and then without needing to worry too much about the details, but then just wanted to create them in a mass quantity, those are usually go for our Genie product with the 3D generation.
Also, to add to that, around like a year before we launched Genie, we also had this product called Imagine, which was like a precursor to what Genie was. But the thing was, it took 1 hour to generate one 3D model, whereas Genie takes 15 seconds to make something. It's like in the 1 year span, like sort of like software architectures increased, some research got in, and like the power in which we can use the like compute and like the GPUs also kind of improved. And that's where like it sort of made sense to start building something like on a bigger scale with Genies. That's when we sort of wanted to full on go on Genie and like build it and ship it. So yeah.
I think personally, if I look at both products, the interactive scenes, that was just the one that slightly captured my imagination a little bit more, where I see these representations of, I think you've got some examples up there, like, there's like a plane in a hangar, and I was like, oh, this is cool. Like, I like planes. Yeah. So there we go. But at the same time, you require the user to kind of input quite a lot from their side to make the output possible, I guess. Whereas, as you said, Genie, all I need to do is think up something and put it into a few words, and then suddenly I have an object. I mean, is there any application or is there any kind of plan to kind of go from the generative side, go from 3D objects to creating scenes, for example? Is that kind of where things could go, or would they go there?
Yeah, I think that's definitely something that we plan for. And I think you mentioned a really great part. It's just like, once you can generate something, then it's much more easier. But what it can also do, that something that cannot be achieved in capture, is you can create totally imaginary things. And that is a crucial part for industries like gaming, where if you're an independent game developer and then you want to create a whole like scene of like this world where maybe it's like all these imaginary creatures live that never existed before, you can actually use Genie to create that, because it can create scenes that not just in real life, but also completely imaginary. So we actually seen people in some of these sandbox games where it's easy to create like user generated, like really simple indie games like Roblox, that people have been using Genie to create the assets for their games. And actually Roblox have this like accessory library where we actually found out that some of our users are using Genie to create all of these like accessories in their repository, and then they'll be able to earn the virtual currency on Roblox. So that's like one of these early use cases that we've seen people exploring Genie. But as you said, eventually we do want to create larger scenes, and we eventually wanted to create something that can not only be a 3D representation, but can also interact and move through time. And that's going to come a long way with the further development of like these like visual AI models. But then eventually the hope is potentially have the possibility to become a new, easier version of game engine, to be able to create larger scenes, larger interactions, or even gameplays for people to turn their imagination into reality, to make everything into kind of like a game, but not those kind of professional games, but just interactive experiences that they can play around with.
You've mentioned gaming a couple of times now. Is that kind of do you think that's kind of the core use case immediately? I think on the Luma website, mentions also things like e-commerce and VFX. Yeah, these just feel like industries that could benefit from Genie. Could you speak a bit to sort of what are the other industry applications, I guess?
Yeah, definitely. So I think Genie is more potentially for gaming market, but we also seen people are just doing it for fun. Like it's not that helpful for some of these more complex like game development flow, but then people just create these simple, like even putting their Genie generations into an AR experience and make it more into a kind of experience, not so much as like games, but a less version of that. So I think that's something that after we release the model, we've seen how the user interact with it and learn, and then kind of think about, what this could lead us to. Right? But there are also other industries, especially on the capture side. So the capture side actually have been used by a lot of these like videographers that want to show their creations or their ideas in a different format. So imagine if you're shooting for like a commercial, you can actually show things in a 3D representation. And this could have a lot of the potentials for some of these, like for example, a shoe ad, to be able to demonstrate that. So advertisement for some of these like videographers who are doing these like showcase videos, and also e-commerce have been some of the prominent use cases or industries that we've seen interacting with the capture product. And in the future, I think also for Genie as well, if they have this strong demand for a 3D interactive immersive display, then we believe some of these like VFX artists, a lot of these like even e-commerce smaller brands or advertisement companies could have the potential to use those products, depending on what style they want their eventual outcome to be, but using these as a way to getting connection with 3D as a content format to showcase to people.
Yeah. Okay. Understand. So let's maybe go to more of the tech side, just diving a little bit deeper. In terms of on the Nerf side, how do they handle, things like specular highlights or reflections? That seems to be the difference between looking at something and kind of knowing it's just a flat object effectively versus 3D and sort of feeling like it's really part of the scene. So how is that actually handled under the hood?
Yeah, so I was also fascinated to learn that like it was possible to do these things in the start. But then when I started looking deep into how these things work, one thing that I realized is it just comes for free just because we do these things in like sort of a 3D representation, right? Just to give some context, right? Like photogrammetry was the precursor to what NURBS and Gaussian splats are today, right? And there, everything needs to be mapped to a material with set of parameters and whatnot. And they have to be sort of predicted based on what they look and sort of do, right? In terms of NURBS or Gaussian splats, one thing to sort of keep in mind is that we should forget everything that we know about traditional 3D formats that have been existed so far, and then like have a fresh mind, because everything might be a parameter here or like a billion parameter function here where you can just change a few things to sort of see changes, right? So in terms of how they work, right, since we are looking from different angles for the capture product, right, you basically know what the color is from different angles and across different points in space. Now, if you just put them together, you basically see them like reflective or like specular. So that's the key sort of difference between like traditional 3D model materials and how we do sort of specular and reflections in NURBS and Gaussian splats. So yeah, that's how it kind of works.
Got it. Okay. Yeah, I think that's a good way to explain it. Just that idea, we're actually kind of working from almost like a new primitive here. This is not probably something that people have worked with before conceptually. I mean, again, when I sort of saw, I guess, the interactive scenes, my mind jumped a little bit straight to something like Maps, a Maps app of choice, effectively. And at least in the last 5 years, maybe I've, been more aware of if I go into the sort of photo view and then start zooming down and I start seeing kind of 3D. Is that where this could also go as well, where we could start to have that? But I think that kind of leads into a second question, which is just the computational requirements of all this, like where are the limits today and like where do you see the limits being in the future? Obviously, it's a slight open-ended question based on, where GPUs are going, etc. But
from what I see, today's Apple ecosystem, iPhones are like really good at like sort of rendering 60 FPS native Gaussian splats. I mean, that's what we have today on our iOS app, right? But at the same time, we just launched our Android app a few weeks back, and then like we also made this native renderer on like the Android app. One thing that we see is, Android ecosystem is fragmented, and like each company or each model will have a different GPU, and like generally ARM Cortex like GPUs are like sort of a little underpowered than iPhones. Probably it will just catch up to the iPhones level in a few years with Qualcomm sort of doing a lot of research and like sort of increasing their sort of packaging the compute into smaller sizes. But yeah, at the moment, from what I've seen, us or any other company working on this sector, I see like it's really good, like sort of rendered at 60 FPS, usable frame rates on like iPhones today. So yeah, that's the current state at the moment.
I mean, so that's, I guess that's if the consumer themselves are running it on their device. Like, what about if effectively that's just a client through to, I don't know, like if Luma is running it on your side or another company could reserve a GPU instance, like, does that make sense in this kind of context or application?
Yeah, so there are two things when we sort of talk about this, right? One is training the nerve that today completely happens in the cloud. Today we have like a super optimized pipeline where when you upload a video or use one of the apps or use the API, you basically get the trained radiance field network in like 20 minutes. That's the one side of things. At the moment, as I said, we offer that API or use one of the clients. So we have like flexibility to go white label or like use one of our clients. The second part is the rendering. That's what I think you kind of wanted to sort of talk about. We kind of have two ways to render things also. One is cloud-based. So you can sort of make the camera move around or upload your own camera path and like sort of get it rendered on the cloud. Or you can use your iPhone or like Android app to sort of do it on the app. So that thing runs on the client itself. So there is no server call or like server compute required there. And that works really well on iPhones also today. Like the reshoot capability is what we call it.
Got it. Okay. Yeah. Thanks. That makes sense. I mean, are there, outside of computer graphics, if you want to kind of make that generic phrase, are there any other sort of applications that seem obvious here, like, computer vision, robotics, any other domains that you're kind of exploring, or just you kind of know that this is where it could go?
Yeah. So one thing that we have seen is like people in the robotics industry showing interest on using like sort of these Gaussian splats or nerves. The reason being like you can let a robot roam around and like do unsupervised learning. So that's one use case that we have seen across in the past few years. So yeah, robotics is like, I know some of my friends are also working on this like sort of area, trying to use nerves and like sort of basically use it for training data. Basically, it's like synthetic data, but basically from real world locations, and let a robot train on that. So yeah, that's one use case.
Well, I'm only going to hope there's one application for that, which is my robo vacuum cleaner, which is just way less smart than I hoped when it comes to understanding the room that it's in. So yeah, if it could take advantage of this and start to properly visualize each room, that would be fantastic. But I think we're probably a little while away from that for various reasons, cost being.
Yeah, I actually think that it's being used more on autonomous driving cars. So I actually know that some of these like autonomous vehicle companies are looking into nerves, but probably too costly to build right now for a vacuum robot.
Yes, yeah. I'd hope it was, to be honest. Yeah, I hope that wasn't where people were going with this right now. Probably way more useful applications of it.
And also in the sort of industry sectors, digital twins is one other sort of use case that nerves or Gaussian plots are really useful. I started my career building like prototypes and like sort of digital twins and whatnot. Having an actual representation of what the machines are running in like factories and whatnot, and like sort of viewing it on a VR or AR headset, that's like really sort of gives you some context on what you're working on for the engineers who are like doing big machines or like whatever. So that's one use case also for nerves.
Yeah, lots of possibilities, which is very exciting. So let's move a little bit to just kind of the community around Luma AI. I mean, it seems, I think, Barkley, you touched on it a little bit already with Roblox, for example. It seemed, I mean, to me, Genie especially seemed like a pretty obvious place where you're going to have a kind of creator community as a sort of part of the product almost. I mean, could be very true also for interactive scenes. Again, you've got to input your own things, and then if you want to share them, that's cool. But I guess almost the tangibility of these objects that then people can do something with maybe lends itself more to creator community where, I can take an object that someone else made and do something with it. Like, what's been the approach that you guys have taken to community sort of so far? I guess I'm thinking especially from the game side, and I play, for example, City Skylines, which, from day one had such a community creator focus. It was like they were not going to release the first version of that game without creator community being part of it, which I found super interesting, but it makes complete sense now. And I almost think, to me, that's almost a game that could also benefit from this. If I could type in like, generate this exact building from, a city or from a point in time, and then that gets generated and I can put that in my city or something like that. But yeah, going back to the question, I guess, what has been the approach of Luma AI to community, and sort of what does that mean for Luma AI?
Yeah, definitely. I think quite surprisingly, Capture has been the product that attract most of these communities' attention. Since for Genie, yeah, it is cool that you can type in text and then be able to generate 3D objects. But in a lot of the cases, when people share these on social media, like 3D object itself is not the center of the focus, right? It's usually, it needs to be integrated into like some more complex like gaming experience or AR experience that sometimes it's really hard to showcase since it's more like a game or like for things people to interact with, to experience. But for Capture, for interactive scenes, that actually just gets natural attention on social media once that posted out. So interesting fact is when our product was first launched, we didn't do any of these advertisement. We simply like just posting on our social media channels. And we just started to see these growths in all over the world of people trying this out and then just marvel at, oh, this is what you can do with just your phone. And then that's amazing. So one of the cool use cases that our users have found out themselves is that by using the reshoot in Nerve, by recreating that scene that you captured, you can actually simulate a drone version of flying into that object, even if you just shoot it just with your regular camera and then walk around to capture that thing. So a lot of these people use this to make a drone version of themselves or of their like beloved cars, motorcycles, and then showcase them on social media, which then sparked this wave of like people capturing these drone views that we just didn't anticipate in the beginning. And it's not even in the United States where we're based off. It's a lot in some of these countries like India and Indonesia where people are more excited about these new technology. So as we found out that these products have these natural attention on social media, we just start to feature some of these like really good captures on our profile page. So if you go into the front page of Luma AI app today, you can see a lot of these handpicked good captures where people created and captured different kind of scenes or objects, and then we want to showcase to inspire other people on what to create. But I would say the remainder of the growth comes majority from social media where people are collaborating with us. They want to showcase a really good capture and they tag us on social media, and we just try to further amplify that. So yeah, that's something that we're also hoping to do with Genie side as well. So we have been seeing some of these more advanced creators being using Genie to create these awesome experiences. But admittedly, the bar for using the Genie creation and then further create something that's visually astounding to people, the barrier is still much higher, which is why we actually still right now, like most of our social media attentions have been focusing on the capture product. While Genie is more, I would say, a functional product that's useful for people within these like vertical industries like gaming, like advertisement, e-commerce, etc.
Yeah, I guess with Genie, it really is effectively a prompt engineering economy in that sense. I remember, I think before ChatGPT came along, people started sharing images on, I guess it was on Instagram. And the thing is, they wouldn't say how they'd created them. They just said with AI. But I think that was what people actually really believed, that they had this skill somehow to create these things with AI. And it was, I guess, a lot about the prompting. And it's very impressive. I cannot go into Midjourney and create these images at all. So do you see there being some kind of, I guess, evolution of that within Genie where you have these kind of almost, I don't know, celebrity creators effectively, the people that really understand the Genie product and like how to get the best out of it? Like, is that sort of something on the roadmap, or I don't know, roadmap maybe, but just sort of, is that what you're thinking about? I don't know.
Yeah, I think we have not seen that in Genie. We have actually seen that in captures where people know how to do good captures or just become the role model for other people to follow to take a similar capture. For Genie, I think still it's because currently it can only achieve like creating a 3D model, which is not a complete like consumer experience for other people. Like if you put that Genie model on Instagram, like you can come up with a really creative combination of like, for example, like two animals merging together, like a lion, dragon or something. That would be really interesting at first, but then after the user have seen what's capable to achieve in image land with like Midjourney, with all of these text to image tools, just simply turn that into 3D is not that exciting for them. So that's why for like our future plans, we're still thinking about what kind of experiences that we can enable people to create that eventually turns these creations, these 3D models from Genie into something that can be a holistic consumer experience format that can be enjoyed and interacted by consumers.
Yeah. And maybe you've answered it slightly, but like kind of looking at the next 6 to 12 months, say for Luma AI, from what you can share, like what's the evolution and, you call this multimodality in AI, where do you see that going? And like what specifically can you share from sort of the Luma AI roadmap otherwise?
Yeah, I wouldn't be able to share that much until our model is released, but we are working on very exciting new fronts that aims to eventually achieve like visual creation. So basically turn people's imagination into reality. So Genie is the first step towards that, like be able to think about something and then create that in 3D. But what could that eventual experience be, right? Like people can create these experiences where it's not exactly like a well-defined game, but it could be something in between like videos and games where you can still create these like things on a temporal sequence. Like imagine one of the simple extension that we can have is what if the 3D characters that you create out of Genie can move and can talk. So after that, then it will be something that also not just happen on a spatial scale, but also on a temporal scale that we can allow some of these more interesting consumer experience to happen. So that's where we are working towards on the research side, towards like what we call multimodality or like a general like visual AGI. But yeah, there will be very exciting things that will come out in the next 6 to 12 months or so.
Awesome. Yeah, that does sound exciting. I mean, we've had at the time of recording, I don't think it's live yet, but we've got another episode with another company, different area of this, but AI gaming. And yeah, I can see where the future for the next 6+ months is going to be very exciting, I think, in this space where suddenly a whole ton of possibilities are opening up when we apply this kind of technology to, effectively to gaming is virtual worlds, like think up what you want and then make that into sort of what feels like a real world. So super exciting.
Yeah.
So where can our listeners, I'm sure if anyone, for those that aren't familiar until this point, I'm sure they're pretty excited to go just check it out. So where can they go learn about just this tech themselves, and like where's also just the best place to kind of start with Luma?
Yeah, for Luma, like lumalabs.ai is the website. You can also search for Luma AI on the Play Store or the App Store. You can find the app pretty easily. And in terms of trying to learn about the tech, the interesting thing that I've found in the past couple of months or weeks is that you can ask these really good LLMs to just like make like really personalized answers for you. Say explain me like a 5-year-old or 10-year-old, and you'll literally understand what these tech are. Just go to like Perplexity or ChatGPT and like just ask basically, and they get you the resources for you.
Awesome.
Yeah, I would also add on to say for Nerf, actually the Berkeley lab where Nerf originates have also this open source project called Nerf Studio, which we are also kind of like, since it's all coming out from the similar lab, kind of in this sister relationship with, that they have a lot of these like open source solutions or stacks that's needed to explore Nerfs. And there's a lot of like learning resources and papers that these researchers who came up with it have written.
Awesome. Yeah, it's always exciting when there is, a very like powerful open source part to this that people can go and play around with as well. So nice. I'll be checking that out. Well, thank you to both of you for coming on today. I've learned a lot. I'm sure our listeners have learned a lot. And yeah, I mean, this is obviously still pretty nascent space. And I'm sure we'll be talking again probably in like a year when we get to see some of these exciting things that have been coming out. So yeah, look forward to following along.
Awesome. Yeah. Thanks for having us.
Thanks for having us.